I'm sorry for that. Should I take this? Okay. Okay. So you hear me better? Okay, fine. As I understood what you introduced my name and my current position, I'm not the director of the institute, so I'm just the institute manager. This means one step behind the director. We have still a director, but the director has a lot of work to do and on the desk, and sometimes the work falls down because he has too much to work. And I'm the institute manager. I keep the overload on work from him and help him to work. So anyway, I'm an institute manager. I like to start to give you an introduction about. I'll take this one. No, it's too far. You see here is an overview what I like to give you on my presentation, a short introduction, what I like to talk about, a little bit about driving forces, and then I will go more in detail, a little bit about source apportionment on the regional scale, and source apportionment on the local scale, what does it mean. And finally, I like to talk a little bit more about the Urban Island project, what we had, and in general about Urban Island, Heat Island, and finally I will give you an idea what we are going to do in the future, or what the needs are, what we have to do in the future about the scientific work in the urban agglomerations, or in cities, in megacities, in small cities, whatever. No. Just a short introduction. You all know it. You live in a large city, but maybe there are some points which are very interesting for you also. You know, in 1900, about 3% of the people were living in cities. Already in the 50s, we had a third time 33% of the people, and since 2007 we have a very important point reached that 50% of the people live already in the city, and in 2030 which will be much more than 3 out of 5 people will live already in cities. So we have to focus much more on the cities in atmospheric science, but also in other disciplines, because here are the people are living, here are the points where most things happens. And another very important point is that 50% of the people live in megacities. This means 10 million and more, and we are approaching cities with 20 million, 25 million, and even maybe Mexico City and the urban surrounding of Mexico City have close to 20 million, Puebla and so on. And if you take everything together, in a couple of years maybe you have also a meta city here in this region. The same happens to Beijing and Tianjin, where this terrible catastrophe happens a couple of weeks ago. So this is also a region which merged together. And we come already to the point which are very important, that urban emissions have a significant impact on the global greenhouse emissions, 5 to 10%, which have been evaluated by Butler et al. And a very important point is that 75% of the material flow in the city is realized in the cities and not outside. So we have a lot of flows in the city coming to construct cities or whatever, and this is a very important point for future resources already. And I mentioned already, urban emissions have a severe impact on global greenhouse emissions, but also on the impact on air quality and the regional climate. Not only in the global climate, but also in the regional climate. And we all suffer already on the change of the global climate, and we have to work on this much more as before. And you see also I have here some new publications. This is, we know it since a couple of years, we know it since decades, but still there's nothing done in this way, that we have to concentrate a little bit more on the urban emissions. And other way around, the climate change which happens at the moment has also a strong impact on the urban agglomerations. Just thinking on the heat island effect, this will be much more as before. We have more influence on the heat in the cities as before, and we have also different related processes and atmospheric flows in the city or around the city. The flows will change and the chemical composition will change or has changed already. This we have to consider in our scientific questions and focus on. And air pollution levels in urban areas depend not only on the local emissions. It's very important that we have local emissions from cars and so on, but we have also the regional emissions. We have to look on the rural interactions between the city and the rural surroundings. It's very important because the most biogenic emissions come from the rural, and you can imagine if these emissions come together with anthropogenic emissions in the city, we have a totally different mix, and this gives us new approaches and ideas what we have to do also for simulations and for the measurement devices. Talking a little bit of the driving forces, why do we such research? What is the background of this research? And my point of view is always we like to have a better quality of life. This we need, and I think it's very important. We have health-related problems in cities, and we like to increase our well-being in the cities. This is very important. We like to increase a better on the atmosphere. We like to have a better atmosphere. We like to have better water, available water in the cities. The scarcity of water is more and more coming up. And we like to have also a nice biosphere in the city. We like to have proper soils, and we have to have clean soils. And all this depends on the quality of life, and this is the most important point why we are doing this research, in my view. Maybe other people have a different view. As a second big driving force is the climate change. We all know the climate change is coming. We have a climate change already, and we expect extreme weather situations in the future. Maybe it's not so to feel here in Mexico City, but on the coastline or in America or in Europe, we feel really that the climate has changed and we have more extreme weather situations as before. And another very important point, the people getting older and older. It's nice that we're getting older. I hope we all get very old, but this has also an impact on the life in the city and in life in general. So we have to adapt on the needs of the older people. We have to adapt the streets, we have to adapt the shopping malls, whatever. And this has always impact on also the atmospheric and the climate situation. So the mobility, we will have in future a channel. We will have always mobility. We are mobility people, and so we have to adapt those systems a little bit more in a scientific or in atmospheric ways that we have less emissions. So we have to think about modal split. So we have to think about different traffic systems, bicycles or whatever, and with less emissions, for example. And then we have to manage also the nature risks and anthropogenic risks. So you have here, for example, the nature risk of maybe of the volcano Popocatépetl, I think it's okay. And but you have other management nature risks in other cities where you have flooding or mudslides, which are very important for the cities, and so we have to manage this system. And we surely have also inaugurated some anthropogenic risks because of such a lot of people live in such a close surrounding. We have a higher risk than if you are working or living in a rural surrounding. And we have to look forward also about the scarce resources. We need a lot of resources to build cities, and we have in the future we really scarce resources to build these cities. So we have to construct the material from the cities. We have to take these sources out from the city and take it as a real resource for the future, since this is also a very important point. And not quite sure. We have also to look at the sustainable development of cities, which includes also the points before. We have to look at the city planning and the construction of cities that are really staying and is this sustainable enough also for the future and can manage also future problems which come up in next 50 to 100 years. This is already done in some times. We had some projects, and we had, for example, the risk habitat megacity projects. I had here a presentation already about this a couple of years ago. We have been in Santiago de Chile with different disciplines together, and we tried to look at the risks of a city like Santiago de Chile, and all the things that I mentioned before was a little bit tried to keep together here in this different disciplines: land use management, social spatial differentiation, energy system, transportation, air quality and health, for example. So we tried already to do a little bit this working together over the disciplines, but we have to do much more. This is just the first small step that we have done, and we have learned a lot of this from this project, and now we try to step in next in a different future to have much closer cooperation with these different disciplines. And in order to give you an idea, also this UN has here made a presentation. I have here a small video which is very important, I think, to all of us, just to bring the things together.
Is the city of tomorrow already here? The high cost of energy, crime, choking air pollution. Around the globe, these 21st century challenges are all being met with real innovation. In England, wind energy from the Atlantic is powering London homes. Police in Los Angeles are crunching big data to solve everyday crime. And in Seattle, one building is redefining what it means to be green. Real solutions, but the challenges only grow bigger. According to the UN, the world population will reach 8.3 billion by 2030. In that same time, greenhouse gases are expected to increase by 25%. The world's trash nearly doubled, while half of the world will live in areas threatened by lack of water. What does that mean for cities? 60% of us will live in one, and by 2050, 70%. And the demand for clean air, water, energy, and yes, convenience will skyrocket. By 2017, nearly half of the world's population will be online, and almost half of all internet traffic will travel through smart devices. Imagine fewer drivers commuting to work, smarter policing, buildings with no carbon footprint, and trash cans that tell us when they're full. Life in the city of tomorrow could be pretty great if we develop the technology we have today.
So you see, they are professions. They can bring things much easier together than I. But I have the same arguments that they have been done here in the video. And before I found this video, I put the things together from the scientific point of view. And then I found this video because just by chance. And I think this is it brings really the things on the point and what we have to do in the future. So all in all, it's really a complex system. So you see, we have a lot of puzzles which everybody is working with their own puzzle. Everybody is working in their own field. But how did these different disciplines, how do they work together? How fit they together in the future? This is very, very, very difficult. So I like to give you some small introduction, some small views in the specific things what we are doing. This the presentations and the next phase what I have about some PhD thesis which we have been done in the last 3-4 years, 2-3 years ago. And so the first point is example Beijing about particles. You see here the particles have an influence on climate and human health and visibility. Maybe visibility is not so important, maybe for airplanes, but I think climate and human health is the most important point. And what we see for Beijing is that the PM10 concentrations go a little bit back, the mass concentrations as a yearly mean, but it's still very high, so you can be happy that it's decreasing, but it's still beyond a normal situation. And the same happens also to PM10.5. You see the standard worldwide, we have different standards, and the European Commission, US has a highest one, WHO also, and in China, in Beijing in 2013, it's beyond all discussions of PM 2.5, so we have to do something, or the people have to do more research in this area. And some small things what we could do in this part, we have done in two of these PhDs. One is one problem that they have in Beijing is the dust impact on the city itself. So it's really, we have to go into regional investigations. We have to look what the regions bring inside of the city. And you see here, for example, a time series of PM10 concentrations, and in the end of April, we see an increase up to 1200 micrograms. It's amazing high, and this is due to a reported dust event in the city itself. And you see it in three different stations in and around Beijing that they have high concentrations here. This was done these investigations was done in the PhD thesis of Stephanie Schrader, 2014. She finalized it, and the aim was to investigate of the impact of natural and anthropogenic gases and aerosols on the regional to continental scale. We used for this, she was using Cosmo weather forecast model of the German Weather Service, and with a simulation in art. This was developed in KIT for the aerosols, and the feedbacks we had on meteorology, gas and gas phase and dynamics. Before I come to one of these results, what you got, you can see what the dust event means in Beijing. A dust event means really you see nothing. You have really a severe impact on the cars and the streets and everybody. So it's better you stay at home than to go outside during this severe impacts what they have. And we have to know where it comes from. What is the reason that we have such an influence in Beijing? And she does, Stephanie Schrader does this with a simulation of Cosmo Art, and you see that one of this outcome was that she classified different regions. You see, at least this is approximately China here, what you see. And she classified the different deserts in the region of China. We have here Taklamakan and Gobi, this is these deserts, and we have Inner Mongolia desert. They are classified by different size of particles and different soils, so you can really differentiate. And the main impact what they got from in the model, by the model, was from the Inner Mongolia, by the very close to Beijing. And the impact was also that they have a steep gradient from higher altitude, where the Inner Mongolia area is down to the lower altitude of Beijing. This is also increasing the event of having such the dust event. So you see, the regional identification of different particles is very important, and we could, in this case, we can do it by a simulation of this system. And now we have developed the Cosmo Art, can now be used for mineral dust forecast in Beijing, and I think in China and Beijing, I think this is a very important step for this small part what we have done here. But we have also to have local investigation. We have to look really into the city, what happens in the city. And you see here also from the PhD thesis from Wang Sheng, we have a clear sky here with 50 microgram, and we have 344 microgram with really a haze situation, and it's very, very important. What is a haze? What is a haze? What happens within this haze? And you see also we have here geogene particles. This means really dust, and we have here the anthropogenic particles. So they are quite a little bit different from here to here and from here to here. So we see this a little bit difference of the anthropogenic particles, and we have to investigate much more. So Wang Shen did a methodology with different sampling on different sites in northern city of Beijing. We have here 2 sites where she was sampling. This was not so easy to get these locations, and with a high volume sample she was sampling in the university and in the research center of Institute of Atmospheric Physics. More than 1 year she was sampling and analyzes the different samples. We have 2 samples. One was on the organic composition. She was looking on different stamps on the sample part, and we had here, for example, the interesting things of toxic assessment, organic, spare, toxic assessment in different isotopic extraction, and we had a large cooperation of different institutions where they also made this analysis of these filters here. And on the other hand, the sample B is also where she was looking on the PM mass itself, PM 2.5 mass. Yeah. And what she now found out is over this year, we have here the 100% mass percentage of the clear situation in summer, in autumn, winter and spring, and you see we have more or less always the same, around 50 microgram, a little bit low, 750 microgram. We have less in winter time, but you see also during this time we have always very high influence on mineral dust which is coming from outside. In spring it's the highest percentage, up to 60-70%, where we have an impact of this dust. But also we have impact on traffic. The traffic has more influence in summers than in spring, and so this is very important to know where this is coming from. This was a very important step for her to come forward to look what the clean situation is. But if you now look to the haze situation, you see the second column here, also it's a different season times, summer, autumn, winter and spring. You see that we have in summer a higher portion of secondary sulfide formation, biomass burning. Biomass burning was very important at this point, and mineral dust is a small part. And we have in autumn a higher secondary nitrate formation, which is also very important for the ozone formation and so on, and also for secondary particles. And so on. The other one is more or less the same, and you see also the mean values are very, very high and far away from the standard what we can realize. So this first apportionment analysis was a very important step to know where these things come from, in order then we can feed the models and the regional models, and then to look forward to make forecasts and so on. So to summarize this a little bit, so mineral dust was very important, and it was coming from the inner Asia less and desert areas in combination with this topography, very important, which have a significant impact on the local air quality, and possibility of mineral dust reduction would be the blending of specific grasslands in the deserts, or recultivation of steppes, or cold degradation regions. They have a lot of cold regions in the Inner Mongolia, where there are open sources for dust, and so they have really to degrade these regions much more as before. Haze was defined as fine and anthropogenic particles, and we have to have stagnant weather situations and conditions, then we experience these haze situations. We have different seasons. Haze can come up up during different seasons. They have different sources and different source regions. This is also very important to know. And we have to reduce NO3, SO4 and NH4 in the regional scale, not in the local, but in the regional scale in order to have the haze reduction in the region of Beijing. Quite sure, it needs a higher standard of cleaning equipment. Road cleaning standard is very important. Emissions from construction dust is also a very important point in order to reduce this haze in Beijing itself. So coming to another point, urban heat island phenomenon. I think also you suffer sometimes from the heat island here in Mexico City, and it's just a definition. It's that the city is warmer than surrounding areas. This is very simple, and but say you can also have specific degrees on temperature, for example. So the annual mean temperature, it's maybe 1 to 2 degrees warmer than the surrounding areas, which is not very much. But if you look at clear nights, we have up to 12 degrees more in the city than the surrounding, and this is already a term of quality of life, that you have a better quality of life outside in the city when the temperature goes down during night. And the city is clearly defined, the heat island is clearly defined by closed isotherms. You see here, it's really like a dome, or like so in the city itself is much more warmer than in the outside. And the heat itself in the city extends vertically to form an urban heat dome. This means that we have a different circulation in the city. This means we have an updraft of the wind and the atmosphere, and so the whole substances of particles and gases go up and go outside to the city. This is a totally new information which we have to consider in our models in order to simulate the correct concentrations of the different particles. Here, once again, you see a little bit about the intensity of the urban heat island. The intensity is mostly during night, when the real is going really cooler than the city, and during the day it's very close by each other, but during night you have the most important difference between rural and urban situations. And you can also see a dependency on the population of the city. And for example, in Europe, you see if you have 4 million people up to 7 million, you see here that there's an increase on the urban heat island effect, and the temperature from 6 to 10 to 12 degrees. The same happens also in America, North America. As more people live in the city, as large as the city is, as more is the heat island effect tendency calculated in degrees. So what we have to do with this, what can we do with this is the question. What can we do with this urban heat island effect? We can increase, for example, the albedo. You know, in Greece they have done it already. The buildings in the island are very white. So this can at one point. We can green, for example, these high skyscrapers. We can plant more plants in the streets. We can look that we have a decreasing runoff of water, so that the water stays a little bit more in the city. This is also very important to cool the city. And we have to look that we decrease anthropogenic heating, air conditioning, that we have to decrease a little bit in this way. Also industrial facilities emit a lot of warm and heat in the surrounding. Oops, it's the wrong way around. Yeah, and what is the benefit out of if we have such mitigation measures? So meteorology is quite clear. We can reduce the temperature. We can also reduce emissions and aerosols. This means also we have a benefit on air quality because the photochemistry is maybe different, and we have a quite high impact on human health, on morbidity and mortality. The heat stress is less, and so on. And also, finally, we have also an impact on the economy. The healthcare system is not anymore such important, and the energy consumption also. So we have done modeling investigations with WRF and later on with WRF 10. We have introduced in the normal WRF a parameterized subgrid scale processes with the urban canopy model, and they consider 3 different urban buildings around, with high, low, and commercial buildings. And with this we go forward in the PhD thesis of Joachim Fallmann in the city of Stuttgart. Stuttgart is a small city in Germany, but Stuttgart has really a problem with the heat island effect because it's lying in a valley, and the atmosphere and the wind cannot really escape from the city, so everybody is stacking inside of the atmosphere, stacking inside of this valley, and so have a severe problem. And he made different simulation mitigation strategies. So he made all buildings white, he made a lot of parks, different parks, he made a central park, and here you see just the control situation. You see, these different mitigation strategies lead to different temperatures in this area, and the most important point was really the albedo. So they had a decrease of temperature up to 1 to 1.5 degrees. And you see here just a summary of the impact of the mitigation strategies and the heat island effect. And you see here a picture of Stuttgart, fair weather situation in summer. Here we have really fair weather, but due to the weather situation, we have 150 meters above ground, this inversion layer, and during cold air we have this situation like here, but then we have really the impact of the heat island. Oops, it's too far. And the next step was, we have thought about that the impact of heat island effect is not only on the temperature, on the meteorology. So if we have an impact on the meteorology, it should also have an impact on the air quality. And this is a very important point. If we turn one screw, we have to also to check the other screw, what happens with the surrounding, with the atmosphere itself. And when we look here on this graph, you see here, for example, this is a control. The dark one is a control one for different concentrations of NO, NO2, ozone, and CO. What you easily can see is that when we have all buildings in white, we have an increase of NO concentrations, CO concentrations, and NO2 concentrations. And it's quite clear the increase comes from the atmosphere, because the circulation is reduced, because we have not anymore this heat which builds the heat dome in the city. So the circulation is reduced, and then we have a higher concentration of these primary emissions, and this is a problem that we have to configure it and to work with. And on the other hand, we have also a reduction of ozone, or sometimes also an increase here. You see, albedo, we have a decrease in the region, in the city, because we have more NO, so we have also less ozone in this region. And if we have a park situation like here, we have also in the surrounding, we have a little bit higher concentrations, but less inside of the park, and the higher concentrations around happens also due to the BLVCs. So we have higher concentrations of ozone because we have more green emissions and VOC emissions in the city. So I think this was a very important step to see that the urban heat island effect and the mitigation strategies have a different effect also on the air quality. Coming now a little bit to the future, what we are doing in the future, what maybe impacts all of us in the future. So we see the urban-rural interactions as a very important point. So the action between the surrounding of the city and the city itself has to be considered in the simulations in all ways of in different disciplines. And we see the cities also as a reaction muscle, because here we have we have high concentrations of different BVOCs, VOCs and anthropogenic emissions. So this is really a reaction muscle which we have to consider in the future. Driving forces are really the anthropogenic and biogenic emissions. Also, driving force is the land use change. You see it also in Mexico City and the surrounding of Mexico. So the land use is changing a lot, and also in the future, and this influences also the atmosphere and the chemical substances and the reactions. We have a change also in the radiation and the heat budget in the city and also around, and the driving force is also climate change, which was already mentioned before. Resulting impacts is what we are looking for as a heat island effect. The composition and dispersion of pollutants is very important. How these pollutants disperse around the city and in the city itself, in the vertical, also to the rural side. And we concentrate in the future also on adverse health effects. Here we have a running PhD. She's going to look on the impact of, in a small scale, the impact of different pollutants and concentrations on the health with high resolution modeling, which is not done before, and so she's concentrating on Munich and Augsburg in Germany on her PhD. The challenges are really, we have to consider the relative contribution of anthropogenic and biogenic VOCs. This is not really done now in a proper way. You see, we have much higher concentrations of biogenic VOCs than anthropogenic VOCs on the global side. So we have to really look at our emission inventories and concentrate really on the emission inventories to get the biogenic emissions from the plants very correct into our emission inventories. Then we have to concentrate on the aerosol chemistry and physics. Here we see an example from Karlsruhe, where you find on power plants a high concentration of very small particles close to the power plant, but if you go further away, the particle size changes, and this is also very important to know how the changes are going and in which direction this is going. Have this influence on the climate change, have this influence on the clouds around the city and so on. This is one of the points. Some I mentioned already the impact of anthropogenic, biogenic emissions on the urban climate and health, this chemistry and reaction muscle, and we have also to look on the urban system with to concentrate on mitigation and adaptation strategies. This is the most important point. It's not only that we produce results and to say, okay, we have now new results from the model, but what can we do with these results? This is important. Where we can go into mitigation, adaptation strategies, what we can do, what we have learned from this, and this is a very important step. What you have seen before, when we start some mitigation strategies, you may have an influence also to other disciplines, or so this we have to consider in a way to work together with other disciplines. And another very important point in the future is we have to overcome the different scales. We work all in different scales in the laboratory measurements or chamber measurements. We have towers or aircraft measurements, and we have also remote sensing measurements. But we have always in between not very educated interface. So we need really to interface and to link these different scales in a way that we can learn and from one scale to the other. And the same happens also to the models. We have the global scale, we have the regional scale, and we have the city scale, but they are not really linked. We have for all systems, we have different models, and they are a little bit different in the emission inventories, for example, and in the handling of the physics, and so we have to concentrate a little bit more that the physics or chemistry in these models is the same. And what are the next steps? In Germany, for example, we have now or in Europe, an urban research international and national initiative, since the city of tomorrow is going to bring much more money in the future as before. And for example, the German Ministry of Education and Research has a new program established, Urban Climate Under Change. So with different modules, and also our institute is going to work on this module B and A, and we hope that we can really develop such a comprehensive urban climate model and take part in this one. Then there's a Helmut's Urban Research Initiative, which was pushed by our KIT, by Karl's Institute of Technology. So here we have a little bit the idea of an urban research concept which includes engineering, natural health and social science, what I mentioned before, but also we have a very good, on the university we have a very good architecture department and urban planning department, so they should also be included in this urban research initiatives. We have thematic priorities, so we concentrate on the themes on the way, and we have the idea to have a long-term one from 10 to 30 years, which is very important, so you can really see how the change in the cities going on. And we have in mind to have an international pioneering role, and so I hope that we come to a point further than the Risk Habitat Meta City, which was also a Helmut's research initiative. I hope we come forward with this initiative. Also, the European Commission has, in Horizon 2020, has one point as a proposal improving the air quality and reducing the carbon footprint of European cities. The proposals are currently under review. I think there are 15 proposals in Brussels now, and we will see what the outcome is, and then we have also hopefully a further step here in search of the urban city. Then I have also to see the Federal Ministry of Education and Research has announced 2050 as the future city here, so everybody likes to research on the city. He can make and give some proposal, and so it's a lot of money is behind that we force this research a little bit. And I think this is a good idea, and we try to keep this running, this project, and the idea of the federal ministry. I mentioned, I think we know this already, we need a really integrated approach in the future, and we need the land use change, people, energy, mobility, social science, very important. Most of the people forget the social science, that we have to involve them, how the development of society is in the future, and whatever the social science has in mind and to do, they should be included in our research. And only then we can look at the air quality and the well-being, we can look at the health impact, and we have then also to look at the ecological benefit. This is a wrong one. Economical benefit, not ecologically. This should be the economic benefit of the society as of the outcome of this integrated research. So this is the conclusion of my presentation. I think the successful sustainable development of cities needs linked knowledge of the different disciplines. As I mentioned several times before, I always have this in mind, that we should talk much more with the other disciplines. We look further around the horizon. And we should also concentrate concentrate a little bit more on the scenario development and mitigation or adaptation strategies. This is very important because if we think in, for example, atmospheric science in a specific scenario, we have not the views of other disciplines in mind. We have not the views of the city plan in mind. So we have, this is once again the call to talk to others and to talk with other people in other disciplines. And quite sure mobility is very important. I put it as one of these conclusions here. Traffic modeling, traffic emission modeling is very, very important, and the impact on the air quality. This is not on the final stage what we have now. And then we can also look at the health and the linkage between traffic, air quality and health could really demonstrate such linkages, because I think here we are, from the atmospheric point of view, very close to the disciplines already. Other disciplines are still missing, but here we have the possibility to demonstrate how different disciplines can work together. And complex processes can only be described and assessed by multi-scale modeling. Quite sure we need different models, we need different scales, but the complex processes can only be described when we have all things together, all tools together in one hand. It's not the need that we have one model which can everything. This is not possible, but we have to link the different models in order to get an output. And also it's very important to have high quality standards needed for the urban level, but also for the regional scale. Don't forget the regional surrounding of the city. This is very, very important. Also here we need high standards, and not to say, yeah, the surrounding is just a little bit what we have to concentrate on, but not so important. This is very, very important. And I like to give this citation from the World Bank. It is now understood that the battle against climate change will likely be won or lost in cities. I think this is very important. Only when we concentrate on the cities, and here we can learn a lot, then we can also win the battle against the climate change. And I put this puzzle a little bit together. I think it's a little bit less complex, but still we have a lot of empty insights, empty disciplines insights. I have no idea which of those are missing. I think the energy is very important, which is missing. But if we put this puzzle a little bit more together, then we can have a better future view of the cities itself. Or we can do it like easier, maybe make it easier just to overlay all the problems and don't see the problems itself. Yeah, thank you very much for your attention.
Thank you very much, Dr. Sipan. Thank you for your talk. It was very interesting. You showed some results about the heat island and the effect on the temperature, showing that the effect is mostly happening in the afternoon and during the night. Is this considering also the presence in the urban area of aerosols and gases, like greenhouse gases, or is it just changing the albedo?
No, if you talk about the intensity of the urban heat island effect happens during night is because of the heat storage of the building. This is the main point, because of the difference between cities and surrounding. This is the main thing, but not
considering the composition of the.
It's not. I think it's just very minor in comparison to the heat storage of the buildings.
Okay, thank you. Thank you very much. I was wondering, what do you think about this compromise that you will get if you put green roofs and the need to feed those with water? And if you have green roofs, you would have more CO2 emissions. Have you take a look at that type of
Okay. I just can repeat what the PhD thesis from Joachim Fallmann mentioned, and we have an increase of or a decrease of temperature when we have greenhouses or green grassland on the house on top, and if you have more water, you have less temperature increase in this region. I don't know what you mean with what's the impact on air quality. You mean what is the question?
The concern is about basically from cities from here that we don't have that much water.
Yes, this is exactly the point which I mentioned on different points. If we start to think about adaptation strategies, we also should ask other peoples. And this is quite the question to the people from the water, from the hydrology. How can we supply this water in such regions? How can we work with this? So we can have such mitigation ideas, but it doesn't work if you have not the water. And so we have to ask other disciplines how we can manage the system in order to get a greener one. Maybe we can plant grassland which needs lots of water. Maybe we can store water from during winter time when it's raining more than in summertime. So I have no idea, but this is exactly the question what we have to address to the other disciplines, and then we have to work together. I'm only geologist. I have no idea where we can get the water. How can we store the water? We have to discuss with the people from the soil, which look at the soil and the ground, and so on. So this is exactly the point. It's a very good point. I cannot answer it. So
thank you. Thank you for your talk. I would like to know if one of the driving forces that you mentioned was land use change, and that's one of the driving forces that has been worrying us more in the recent studies that we have been doing. Because I think that the morphology or the shape of the megacities is very different between, let's say, a European megacity or a North American megacity to a Mexican or developing world megacities. So some of the driving forces and some of the mitigation strategies might be quite very different between this well-being and northern hemispheric megacities to the developing country megacities.
Quite true. There's a feeling of well-being in different regions of the world is quite different. I'm quite sure. So this is it's not a general approach what I mentioned here, what I proposed here. It's just to have an idea in which direction it can go, and that you should talk with other disciplines. So well-being, it's a big scale, I think, between different cities. Yeah. And the approaches are quite different in Mexico City than in Stuttgart, in Germany, quite sure. But the direction is the same, I think. Should be the same.
Thank you for your talk. It was very, very interesting. My question is probably very naive because it's related to the dome of the heat island that is developing. And is it really like the heat island is developing a dome, or is it actually modifying the planetary boundary layer above it, like regionally? Does it actually changes?
Yeah, the dome which I showed here is really the boundary layer which is getting uplifted a little bit. This is quite clear. So if you have a boundary layer, this would be stable over the same area. But if you have heat storage in between, the dome will, or the boundary layer will be uplifted a little bit, and then you have a dome. And due to this uplifting, you have also different streams of the wind in different directions.
So if this is true, if it is uplifting and you have like an inversion layer at a given height, and we are already talking about geoengineering things, if one will not desire to have an inversion layer during the winter, wouldn't it be better to have like a lot more buildings, so the dome will be a lot higher, so therefore will be no inversion layer no more, right?
This could be opportunity. This could be one of the strategies, but I think this is not a good one. I think we have to find other solutions. And apart from the geoengineering, which is this type of geoengineering, I don't think that this is not what we should go in the future. We should really look at the sources, what the reason is, and we should turn on the screw where the reason is, and not and the result. We should not turn on the result.
Sorry, I have another question. When I was in Hamburg with my colleagues, Daniela Jacob told us about looking into the how the slopes of nearby cities have been changing because people is populating those slopes. I mean, talking about differences between tropical cities like this and northern cities, we have very different reasons why people would populate those hills. But I was wondering, I was always with the question of how that works in Europe, because here if you look at hills here, they are completely full of people, and that changes roughness, changes everything here. And I was wondering if you have looked at those kind of problems in Europe, and if there are other places in Europe where you see this.
It's not always the slopes, but we have the problem in order to get a ventilated system in the city. We have, for example, I don't know, it's only in Germany, but in Europe, the systems that the railway lines go really in the downtown of the city, because they have been built 150 years ago. So these railway lines are not only one railway, 10, 15, 20, which goes downtown to the city. And this is, they have realized this is a very important fresh line air, for the fresh air coming into the city. So this is also very important, not to build buildings in this part of the city in order to keep fresh air into the city. This is one of these points, and the same happens to the slopes on the hill. Also here I know that some cities start to think about that it's not good that the people build their houses on the slopes, because here you get fresh produced air which flows down in the night to the city and brings colder and fresh air in the city. And some cities think about already to stop this. I know this from city planners in Stuttgart and also in Freiburg. So they try to keep the building away from fresh air ventilation systems.
Well, a comment. I was thinking of the graph that you showed that is showing that urban heat is larger during the night. Here we did a research led by Dr. Erika, I think it's the back, where we get different results. During day we get warmer city effect. And I was wondering why. So this is a very interesting point, because here the weather is very different. And it is not just tropical, because of the altitude we don't have these very high temperatures that we have in the coasts. And what we observed was that the latent heat reduced because there were less green areas, increases the temperature during the day. Yeah. And the sunlight is larger than in other areas. But during the night we have, as you mentioned, the effects of the mountains that surround the city. And we don't have very warm systems, because it's not very cold in the night. Most of the houses do not have heaters most of the year. So the result is different. So I was wondering that.
I think it depends all strongly on the surrounding of the cities itself.
Yes.
I think if you have a surrounding which only you have trees and forest around, then you have the most difference between the cities and the surrounding. If you have a concrete outside, or if you have, I think here you have, in this altitude you have maybe less vegetation, I don't know. So you have
the mountains. Most of the city is surrounded by mountains.
I think it depends really on the land and the land coverage of the surrounding of the city.
I agree. But just to try to say that the results cannot be extrapolated in each region because we have very different.
But what we have seen is just that we have there was a statistic about North America, Europe, and Asia with the different cities with different slopes. Yeah. This is maybe also in the direction that maybe in Asia the slope is not so steep as in North America. With the increase of population and increase of heat island. Yes, but this is maybe in that direction. It depends on the type of the city also.
I agree, but I think also that the altitude of Mexico City that is very close to RF, which has considerably less altitude, and the fluxes that cools the area also a lot.
This could be a nice investigation to look at the altitude of the cities and check if the altitude plays a very important role on the correlation between population and urban heat island tendency.
Thank you.
Thank you for your talk. Do you consider the biological particles in a special way, or it's only puts like all the particles that they are in the atmosphere?
And it depends on the model. We consider biogenic emissions, especially with different land surface observations, with good cells, with forest, good cells, with grassland, and so on. This is considered in the model. But you can imagine that the emission inventories have sometimes 5 to 5 kilometers resolution, or 2, if you are happy, you have 1 to 1 kilometer resolution. So it's not always the point that you come to the correct emission inventory, emissions from grassland or from forest, BVFCs from forest, or for example from the trees in the street canyons. This is cannot be considered correctly in the emission inventories until now.
Do you use the Cosmo app?
We use different models, also Cosmo app, but the urbanized part we put into the WRF canyon. Yeah. Okay. This is done only with WRF. Yeah.
Thank you.
There seems to be no more questions, so thank you very much, Dr.
Thank you very much. Thank you.
Los invitamos a un en vivo a la salida.
You see here,
You're famous. Will you be? We were sent from our schools and we have to prove we came here. Thank you so much.
Thank you.
What about the sensitivity of the groundwater emission temperature? Do you look at, for example, have you run a model about?
You are currently the only participant in the conference.